We're going to start off by figuring out how to use our calculators to calculate angles and ratios using trigonometry's sine, cosine, and tangent ratios. Now, not all calculators work the same way. I'm going to use the Windows 10 calculator as an example, but you need to figure out how your calculator works. Now, calculators either calculate our trig ratios in a forward manner or in a backward manner. But the first thing you need to make sure is that your calculator is dealing with degrees and not gradients or radians. So on the Windows 10 calculator, right here I can click on DEG, which stands for degrees, so I'm in the right mode right now. But if it had RAD, which stands for radians, or GRAD, which stands for gradients, I need to make sure that I correct that. So your calculator needs to be in degree mode. Now, if you have a calculator that works in a forward manner, to calculate a ratio, you need to press the sine, cosine, or tangent button first and then type in your angle. If you have a calculator that works in a backwards fashion, then you type in the angle first and then type in sine, cosine, or tangent. So let me show you what I mean using the Windows calculator. I'm in scientific mode and I make sure that I'm in degree mode as well too. The first one is asking us to calculate the sine of 35 degrees. So on a Windows calculator, I could type in 35 and then under the trigonometry drop-down, select sine, and it does the calculation for me. That means that the Windows 10 calculator is a backwards calculation calculator. I have to type in the angle first and then press either sine, cosine, or tangent. Now, you'll notice that when I calculated the sine of 35 degrees, my answer is 0.5735764363 and so on. When you are writing down your answers, you need to keep 4 decimal places, and that's very important. Rounding will cause a lot of errors in your calculations, and by keeping 4 decimal places, you'll make sure that you avoid most of those errors. So my answer for the first question is going to be 0.5735, and the next digit is 7. Now remember, we're only going to keep 4, and because this is a 7, we have to round the last digit up to a 6. So my answer will be 0.5736 is going to be the 4th digit. Let's figure out the next one. Now remember, the Windows calculator is a backward calculator, so I have to type in the angle first. So I'm going to type in 45 degrees, then trigonometry drop down and click on the tangent button. And my answer is going to be 1. The next one, we're going to type in 18, the trigonometry drop down, and then sine. And my answer for this one is going to be 0.3090. The next digit is a 1, so I don't have to round that last 0. So I will keep my answer as 0.3090. Go ahead and try to calculate the other 3, and I'll come back with the answers. All right, let's see how you made out. Now, we left off at sine of 18, so the next one is cosine of 88. So we're going to type in 88 and drop down, click on the cosine button, and we get 0.034899, which means that we have to round the 8 up to a 9. The next one is the cosine of 60 degrees. So I type in 60 first and then cosine, and the answer is 0.5. And because it's just 0.5 and there's no other numbers there, you can leave it as 0.5. But if there were other numbers, you would need to make sure you write them in. Next, we're going to find out the cosine of 75 degrees. So type in 75, drop down, and cosine. And we get 0.2588, and the next number is 1, so we don't have to do any rounding. And next, we have the tangent of 38, and we get 0.78128, which means we have to round that up to a 3. So 0.7813 is the answer for that one. And finally, we have the sine of 7 degrees, and we get 0.12186, which means we have to round the 8 up to a 9. So now that we have calculated all of our sine ratios and cosine ratios and tangent ratios, let me show you what this is actually going to help us with. If we have a right angle triangle, let's take a look at sine of 35 degrees. If we have a right angle triangle, and I apologize for my sketch here, but use your imagination and pretend that it's a right angle triangle. Okay, if I know that there's an angle right here that's 35 degrees, the first thing we should always do is label our diagram. So if this is the angle down here that we're looking at, then this is the opposite side. This is going to be the adjacent side, and the side across from the right angle is always hypotenuse. And from our acronym SOHCAHTOA, we know that sine is equal to the opposite side over the hypotenuse side, or the length of the opposite side over the hypotenuse. How is this going to help us? Well, if we're given a right angled triangle and we know one of the angles, and let's say that we know that h, or the hypotenuse, is 10, and we're asked to figure out what the opposite side is, then we can use our trig ratio. Because we know that sine is opposite, let me just write that down, sine is equal to opposite over hypotenuse, I could fill things in right now and I could have x over 10 because that's opposite over hypotenuse. And I now know, because the angle is 35 degrees, that has to equal this. And so all I have to do now is multiply both sides by 10, and I can find out that x is going to equal 5.736. So using our trig ratios in this manner, we can determine the length of some of the sides that aren't given in a right angle triangle, as long as we're given an angle and the length of one of the sides. We'll be able to calculate, using trig ratios, the length of the other two sides.